and welcome to the Absolute Recap Biology Edition, where we aim to maximize your understanding and minimize your need for memorization. Each episode will recap content, skills, and test-taking tips to help you succeed in May. I'm your host, Melanie Kingett, and your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap lipids. Let's zoom out. We're in Unit 1, Chemistry of Life, Topic 1.4 and 1.5. Our big idea is systems interactions. A common question in one of those get-to-know-you games is, what's your favorite food? True confession, I often answer with butter. I do get some strange looks from the group, but butter is delicious on nearly everything. Solid at room temperature on account of its saturated fatty acids, this lipid is the leader of the pack in my book. Remember, you are what you eat, so everything in moderation, and structure influences function. Time to explore these hydrophobic molecules. Let's zoom in. Lipids are a very diverse group of hydrophobic molecules that are nonpolar. Nonpolar means that their covalent bonds have an even distribution of electrons. No one element is hogging them. As a result, there is also an even distribution of charge within the molecule. This causes lipids not to interact with charged or polar molecules, especially not water. Lipids are water-fearing, as a literal translation of the term hydrophobic. Lipids contain the elements carbon, hydrogen, and oxygen. They also like to hang out with phosphorus, but more on that in a minute. Don't confuse lipids with carbohydrates, which also contain these three elements. Unlike carbs, lipids have a ratio of hydrogen to oxygen that is greater than 2:1. The different lipid varieties will have unique structures for each specific role within organisms. One common group of lipids are fats, containing a glycerol and fatty acid chains. The long hydrocarbon chains are classified as saturated or unsaturated. But what are they saturated with? This is referring to a literal elemental saturation of hydrogens. If all bonds within a hydrocarbon chain are saturated, then the fatty acid tails are straight and more closely packed together. An example would be butter, which is solid at room temperature. If chains are unsaturated, that means there is at least one carbon-to-carbon double bond and resulting bend in the fatty acid chain. As a result, the tails cannot be closely packed together, are less dense, and would be liquid at room temperature, like olive oil. Put 3 fatty acid chains with glycerol, and you have the fat triglyceride, an important energy source. The location and quantity of double bonds further classifies the fat, perhaps an omega-3 fatty acid, or the less healthy and barely found in nature, trans fat.
Hi there, Producer Brad here. You may be saying, what the double heck is going on here? To that I'd say, this is a recording and I can't hear you. Now I'm not usually given the chance to speak on the podcast because I'm not a teacher, in the literal or figurative sense. I was at one point a student and a poor one. Therefore, I consider myself a bit of a connoisseur de tutor, which is Latin for tutor expert. So I know quality tutology when I see it, and the Absolute Recap virtual tutoring program is top-notch. AP classes are challenging, and sometimes you may need extra help. If you are looking for more in-depth, personalized support, sign up for virtual tutoring with your favorite podcasting teacher. Each 60-minute session is held through Zoom and is structured to meet your specific needs. So if you have a big test coming up, just can't master those multiple choice questions, or need help improving your writing skills, we've got you covered. Our tutors provide opportunities for you to practice content and skills with graded feedback. Visit our website to reserve a session with a tutor for your specific subject and time zone. Now back to the recap.
Another important category of lipids includes waxes, which typically contain long fatty acid chains connected to alcohols. They play a large role in water regulation of plants and animals. Those extra shiny leaves are covered by a thick, waxy cuticle to prevent water loss by transpiration. Many aquatic birds have waxy-coated feathers, so that they can be in the water without being soaked with water, just in case a quick flight is required. The phrase, like water off a duck's back, is a well-known idiom that refers to a comment or action having little or no effect on a person. Just let it slide off. Perhaps the most common, or common to this class, lipid will be the phospholipid. Phospholipids are polar. Remember water? Water was polar too. So we should expect a phospholipid to have different chemical properties on each side of the molecule. In fact, a phospholipid is amphipathic,
meaning it has a hydrophobic part and a hydrophilic part. Phospholipids have 2 hydrophobic tails and 1 hydrophilic head. The 2 fatty acid tails contain a saturated and unsaturated chain. The hydrophobic head has a glycerol, a modified phosphate group. This is where the element phosphorus hangs out with lipids, and often a choline group. The properties of phospholipids and their nature of forming a bilayer structure makes them the ideal molecule to make up all cellular membranes. Because the intracellular and extracellular environments are aqueous, the membranes are bilayered with tails facing inward. This allows certain cells and membrane-bound organelles to be compartmentalized in their functions. Additionally, different types of phospholipids in cell membranes allow the organism flexibility to adapt to different environmental temperatures. Lastly, steroids, which have 4 fused carbon rings with attached functional groups. They look very different from any other lipid with hydrocarbon chains, but will still be nonpolar and hydrophobic. You can find steroids in cell membranes, like cholesterol, as well as with signaling molecules like hormones. Time for unit connections. You will find lipids in Unit 2 with membrane structure, transport, and compartmentalization, Unit 6 with cell communication, and Unit 8 with heterotroph energy activity. All right. What about the exam? Be prepared to explain why lipids are nonpolar and insoluble in water, as well as the effect that has on biological processes. You may be asked to correlate their role in transport and communication. Recognize that lipids are synthesized by the smooth endoplasmic reticulum and further packaged by the Golgi, but the specifics of this process is beyond the scope of the exam. You also will not need to know the molecular structure of specific lipids for the test. To recap, lipids are a group of nonpolar hydrophobic biological molecules with more than double the amount of hydrogen atoms for each oxygen. Common arrangements include long hydrocarbon chains attached to glycerols and fused carbon rings. Lipids include fats, oils, steroids, waxes, and phospholipids for the functions of energy storage, water retention, and membrane structure. Coming up next on the Absolute Recap Biology Edition, prokaryotic versus eukaryotic cells. Today's question of the day is about hormones. Besides lipids, what other group of biological molecules forms hormones? For the answer to the question of the day, please follow us on Instagram at TheApsoluteRecap. That's the APsolute Recap. Check out our website, TheApsoluteRecap.com, for episode schedules, study guides, virtual tutoring, and to sign up for our virtual classroom. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Today's episode was written by me, Melanie Kingett. Thanks for subscribing, and don't forget to rate and review wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, Absolute Recap LLC, all rights reserved.